Hornets, thank you for joining me today. Today we're going to be taking a look at the worksheet that I was working with my students today on sum and differences of sine, cosine, and tangent. And we'll be doing sum of each. It is not necessary for you to have the worksheet in front of you, as I'm only going to be doing a couple of the problems to help us understand and see what's happening. Please make sure you have your formulas before you begin. You should know them ahead of time or have them on the side just in case you forget. Notice here they are. The sine of u plus v is the sine of u cosine of v plus the cosine of u sine of v. The sine of u minus v is the sine of u cosine of v minus the cosine of u sine of v. Cosine of u plus v is the cosine of u cosine of v minus the sine of u sine of v. Cosine of u minus v is the cosine of u cosine of v plus sine of u sine of v. Tangent of u plus v is the tangent of u plus the tangent of v divided by the difference between 1 and the product of tangent of u and tangent of v. The tangent of u minus v is the tangent of u minus the tangent of v divided by the sum of 1 and the product of tangent of u, tangent of v. Let's go ahead and begin. Now, oftentimes what we are being asked to do is figure out our own sum or difference. So, the first problem that I've chosen is the cosine of 75 degrees. Notice that we are not told what to add, but what you want to do is you want to think about the unit circle and what we possibly could use. We have 30 degrees, we have a 45-degree angle, we have a 60-degree angle, and we have a 90-degree angle. If we were doing differences, we could then continue with 120 degrees, then 135 degrees, and then 150 degrees. Now, it doesn't matter whether we use a sum or a difference as long as this works. Notice that if I'm using a 120 degree and I take away 45 degrees, I will get 75 degrees. So this is one option. We could do the cosine of 120 degrees minus 45 degrees, or we could work with the cosine sum. Notice that I can use 30 plus 45, and a 45 plus 30 degrees will also yield 75. Now, regardless of which we use, we will get the same answer. They may not look alike, but numerically, if we plug them into the calculator, they will come out the same. Let's take a look at both. So we're going to use our formula first for the cosine of 120 degrees minus 45 degrees. Notice we're going to have the cosine of 120 degrees, cosine of 45 degrees, plus our sine of 120 degrees, and then the sine of 45 degrees. Now, as we do this, we just have to know our ratios. The cosine of 120 degrees is going to have to be 1/2. Notice this is a negative value. The cosine of 45 is root 2 over 2, plus the sine of 120 degrees is root 3 over 2, and the cosine is root 2 over 2. We end up getting negative root 2 over 4 plus root 6 over 4. Because they have the same common denominator, I can write them down over the same 4. Now, we usually put our larger square root piece inside the square root first, and then I would put my root 2. Notice that 6 being larger than 2 is going to precede it. Let's now take a look at the cosine sum. This is now 45 degrees plus 30 degrees. Our formula is the cosine of 45 degrees, cosine of 30 degrees. Then we have a minus, sine of 45 degrees, and then our sine of 30 degrees. Once again, we have to know our ratios. If we don't, this becomes extremely difficult. Notice we have root 2 over 2. We have 1/2. Let's make sure I get that. Root 3 over 2. There we go. Then we have minus, and I have my sine, which is root 2 over 2, and I'm multiplying by the sine of 30 degrees, which is 1/2. I end up getting root 6 over 4 minus root 2 over 4, and because they have the same common denominator, I can put them both over 4, putting the larger square root piece inside first, followed by the smaller, all over 4. Notice that these are both the same answer. It does not matter whether you use the sum or the difference formula. You will always get the same answer. If you had decided not to move the negative 2, you would have had negative root 2 plus the square root of 6, and that would have been a little bit maneuvered differently. Let's take a look at a sine now. We're going to follow the same basic pattern for sine, so we're looking at, in this problem, the sine of 105 degrees. Once again, we can either work with a sum. Sorry about that, Hornets. I had to pause the video due to the lights going out again. Let's go ahead and continue, please. If we're looking at 105, write the degrees up above. 30, 45, 60, 90, 120, 135, and then 150 degrees. Notice if I'm doing a subtraction, I'm going to take 150 degrees and I'm going to subtract 45. So 150 degrees minus 45 degrees will yield 105 degrees. The other option that we would have, let's make sure I have the room here, is going to be a sum. The sine of 105 degrees can be made from, and I forgot to put the sign in front. Joys. So I should have the sine, and now when I look at it, I'm going to try and use the 60 and the 45. So I'm going to go ahead and put my 60 degrees, and I'm adding 45 degrees. Now, notice you may be better off at using your angles in the first quadrant as opposed to finding angles in the second quadrant. As a result, you may find it easier to do the sum as opposed to the difference. Either way, you will end up getting the same answer. So let's go ahead and use our formula. The sine of 150 cosine of 45, and then we're going to have a minus and the cosine of 150 degrees, and then we have the sine of 45 degrees. Sorry, I have to squeeze that in. We're now going to use our reference, our angles and our knowledge of our ratios. The sine of 150 degrees is 1/2. Cosine is root 2 over 2 minus. The cosine of 150 degrees is root 3 over 2, and it is a negative, and we have the 45 degree, which is root 2 over 2. When I multiply, I get root 2, the double negative applies, and I get root 6, it's positive, and it's both over 4. Therefore, I can rewrite them as root 6 plus root 2 over 4. Working with my sine as a sum. The sine of 150 degrees, cosine of 45, I'm still doing the last problem. Let's try that again, please. I'm sorry about that. I hope bear with me as I try it again. So the sine of 60 degrees, cosine of 45 degrees, and then we have the plus cosine of 60 degrees, and then the sine of 45 degrees. Using our ratios, we know that the sine of 60 degrees is root 3 over 2. We know cosine is root 2 over 2. When we put in plus the cosine of 60 degrees, we're looking at a 1/2. And then we have root 2 over 2 for the sine of 45. Notice we end up getting root 6 over 4 plus root 2 over 4, and therefore our answer is root 6 plus root 2 over 4. Either way, we get the same answer. Now the hardest part is trying to ask yourself, what two pieces do I add? And this gets a lot more difficult when we start working with radians. So be aware, it is very useful to list your radians in the first and second quadrant, whether you're doing sine or cosine, and then from those values, try to select the ones that are going to subtract and or add to give you what you want. Okay? Let's keep going. So next, what we want to do is we want to make sure that we have information. So let's say I'm told that I want to do alpha plus beta. Well, they have to tell me information about the triangles that involve the cosine of alpha and the cosine of beta. So they will then tell you, first of all, what quadrant each is in. We need to know what quadrant each is in order for us to have the appropriate signs for those ratios. Once again, both of them in the first quadrant makes it very easy, and that's a good place for us to start. They're then going to tell us something about each of the triangles so that we can figure out the missing angle. Notice we have the cosine of alpha is 4/5. I'm going to draw my triangle in the first quadrant where alpha is identified. I know it is the adjacent over the hypotenuse, and therefore I have 4 and 5. This is a Pythagorean triplet, and if you aren't sure, you can always use the Pythagorean theorem. We will find that this missing side is 3. I'm then going to take a look at the cosine of beta. And the cosine of beta, I'm told, is 12/13. I'm going to set up another triangle. I'm going to put my beta. I know that I have 13 as my hypotenuse and 12 as my adjacent side, and using the Pythagorean theorem, I'm going to get a 5. We're now going to try to find the cosine of alpha plus beta. Now they could have asked us to do the sine of alpha plus beta. They could have asked us to use the tangent of alpha plus beta or the difference formulas. It doesn't matter. The minute they give us the quadrant and the information, I can find every single piece that I need. So in this case, we're looking at the cosine of alpha times the cosine of beta minus the sine of alpha and the sine of beta. Well, let's just make sure we know what the sine of alpha is. The sine of alpha is going to be 3/5. Notice we can find the tangent of alpha as well, and the tangent of alpha for this is going to be 3/4, the opposite over the adjacent. The sine of beta can also be found in the same way, 5/13. The tangent of beta as well. Notice the tangent of beta will be 5/12. We can now do a direct substitution. The cosine of alpha is 4/5. The cosine of beta is 12/13. The sine of alpha is 3/5. The sine of beta is 5/13. And there we go. Now notice I end up getting 48 65ths, and I'm looking at minus 15 65ths. When I take the 65ths, all I have to do is subtract them, and I have 48 minus 15, and I end up getting 33 65ths. Let's go ahead and take a look at the sine. Let's do the sine of alpha minus beta. We know our formula is the sine of alpha, cosine of beta. We have a minus, cosine of alpha, sine of beta. Doing a direct substitution with the information that we have here, I'm going to be replacing my sine of alpha with 3/5. I'm then going to replace my cosine of beta with 12/13 minus the cosine of alpha is 4/5, and the sine of beta is 5/13. When I multiply, I end up getting 36/65 minus 20/65. Therefore, I have 36 minus 20/65. My answer turns out to be 16/65. And that's what we're looking for. Let's go ahead and do a tangent, shall we? Tangent of alpha plus beta. So we're looking at tangent of alpha plus the tangent of beta divided by our, let's see, 1 minus our tangent of alpha, tangent of beta. Now I will point out, if I already know what my sine of alpha plus beta is and my cosine of alpha plus beta, I could always do a direct substitution with the sine of alpha plus beta divided by the cosine of alpha plus beta. I could also work with anything that's equivalent to my tangent. So if I have an alpha plus beta, I have to have an alpha plus beta in both. If I had an alpha minus beta, I could use alpha minus beta. Now, that's just aside, and think about that. Here, I'm going to go ahead and I'm going to use the information I have. The tangent of alpha is 3/4 plus the tangent of beta is 5/12. Notice I'm going to have to get a common denominator. I then have 1 minus, and I'm using the same information, 3/4 and 5/12. One of the difficulties is we do have to get that common denominator, so I'm going to multiply by 3/3 in order to get 12ths. I then have 9/12 plus 5/12 divided by 1 minus 15/48. That means that I'm ultimately going to have to deal with 48ths and then take a reciprocal. So although I end up having 14/12 here, I'm going to ultimately need to get it into 48ths. If I have this, I have 48 minus 15/48, and I end up having 33 again, 48ths. Getting a common denominator, I'm going to multiply by 4 to get 48, and that means that I'm multiplying by 4 and I have 56. Now notice, if I keep going with this, I'm then looking at 56/48, and I multiply by my reciprocal, 48/33. The 48s will cancel, and I now have 56/33. This is the exact ratio for the sum of the alpha plus beta, and this is our goal. Now, once again, it doesn't matter whether they ask us to find a tangent, a sine or a cosine, sum or difference. The process is always the same. We have to know the quadrant. We have to be able to find the appropriate ratio using the Pythagorean theorem, and we use the sign based upon the quadrant. Let's take one that's more complex. Ultimately, the only way we make it complex is by moving the various angles around the unit circle. So instead of both being in the first quadrant, I'm going to let alpha be in the third quadrant, and I'm going to let my beta be in the second. Now, let's go ahead and find the cosine of alpha minus beta, and we're going to be using the information that the cosine of alpha is negative 7/25, and that the tangent of beta is negative 3/4. Notice there's enough information here for us to be able to set up our reference triangle. In the third quadrant, it goes down. We know our hypotenuse is the 25ths, and we know our adjacent value for the alpha is 7. Using our Pythagorean theorem, once again, we can always use a calculator if we don't remember our trigonometry. We can do it by hand if we need to. It doesn't really matter. We're going to still be doing the square root of 25 squared minus negative 7 squared. We end up getting 24. Because it's in the third quadrant, both sine and the x and y's will be negative, and we now know that our sine of this alpha is going to be negative 24/25. We know our tangent of alpha is going to be positive because of the negative over the negative, 24/7. In the second quadrant, I make sure I draw my triangle appropriately, and we have 3 and 4. Notice the 4 is what has the negative, and our hypotenuse is always a positive. Therefore, looking at this, we can now say that for the beta angle, keep in mind the beta angle is right here, and let's just go ahead and put it right there for our sake of argument. And with this, I'm able to utilize my ratios. So I can now say that the sine of this beta is going to end up being 3/5. The cosine for this beta is going to be negative 4/5. We're going to use our formula, cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. We're now going to do a direct substitution with our information. The cosine of alpha is negative 7/25. The cosine of beta is negative 4/5. We then have a plus. The sine of our alpha is going to end up being negative 24/25. And our sine of beta is positive 3/5. Now we know our product of 5 times 25 is 125. We know that 7 times 4 with the double negative will end up giving us a 28. We then have a negative, and this is going to give me negative 72 over 125. Adding them together, I'm just going to end up having the negative 72, and I'm adding 28. I end up getting a negative 44 over 125, and this is the ratio that I'm looking for. Notice it does not matter what actual function they ask us to find, be it the sum difference of sine, cosine, or tangent. As long as they tell us what quadrant the reference angle is in, and they tell us the angle of one of our ratios for each of those angles, we can find the other using the Pythagorean theorem and then setting up for sine the opposite over hypotenuse, for the cosine the adjacent over hypotenuse, and for the tangent the opposite over adjacent. We then find our values, we directly substitute, and we add or subtract. This is working with our sum and difference function identities for sine, cosine, and tangent. I hope this helped, and please be aware this is what we will be working on for the first part of our class tomorrow. We will then continue on learning about and working with the sum and the half angle and the double angle identities. Please be aware I will be expecting you to learn and memorize the double angle identities, but not the half angle. Okay? So after we get done with our double angle identities, all of the other identities will be given to you. Thank you very much, Hornets. I hope this was successful. I hope you understood what I was doing. And if you did not, please remember to ask questions, and I will attempt to do my best to help you understand. Thank you very much, and have a fantastic day. Cheers. Bye-bye.